And look at section 5.2. It says graphing a quadratic function in vertex form. There it is. So it looks like it's on page 11. And there are a couple warm-up problems at the top. Why don't we just do the 2 even warm-up problems maybe? I don't think we need to go through all of them. So let's look at number 2, and then we'll talk about number 4 as a little refresher review. And then we'll talk about this vertex form. So in number 2, Haley, what would you do if it has x minus 5 and then it's squared? What does that mean? Yeah, so we write it twice. And you're going to see that the form we look at today is going to have that quantity squared in it. So we would write it twice. And then it says to find the product. That means to multiply, and we multiply using FOIL. So Haley, if you FOIL this, the first 2 terms, what do you get there? And then perfect, plus 25. Nice job. When you combine those together, we know that those middle terms, just like every other problem we've done, combine, and we get x squared minus 10x and then plus 25. So the other one we'll do as a little review is number 4. Number 4 was what you had your quiz on yesterday. And as I said, we're going to be doing a different approach to graphing today. So number 4 wants us to find the axis of symmetry and the vertex. Bill, how do you find the axis of symmetry?
It would be negative b over 2a.
Perfect. Yeah, negative b over 2a. So if I label a is 1, b is negative 10, and c is 5. So labeling those 3 numbers, assigning values for a, b, and c. And then we plug them into the equation or formula that Bill gave us. In parentheses goes negative 10, and also in parentheses goes the 1. Bill, a negative negative makes a?
Positive.
And then we have 10 over 2, which gives you?
5.
Yeah, nice job, Bill. So x is equal to 5 is the axis of symmetry. So the next step, we need to find the vertex. And to find the vertex, we know, I'm going to put AOS, axis of symmetry. We know the vertex has an x value of 5. So you find x and then you plug it in to find y. So we have 5 for x, it's squared. 10 times 5 and then plus 5. Jason, what is 5 squared?
25.
And then Jason, the next 2 numbers, negative 10 times 5 makes?
Negative 50 plus 5.
Awesome. And then if you take negative or 25 minus 50, you get?
Negative 25.
And then when you add 5, Jason, your final answer for y is?
Negative 20.
Nice job. So my vertex is 5 and negative 20. So that's method number 1. This method for graphing is called the standard form. We are going to do a different method, finding the same information, but finding it differently. So we're going to use a different approach.
A little easier.
So that takes us to vertex form of graphing. So again, we just did standard form all last week. You took a quiz on it yesterday. And now we're looking at vertex form. So vertex form still says y equals. There is still an A in vertex form. But vertex form has parentheses that are squared. And inside the parentheses is x minus h. There are different letters in vertex form. So the A is the same, but there's not a B or a C. Outside is a K. So vertex form looks a little different. In this vertex form, it's called vertex form because the vertex is directly in the equation, which means you don't need to find it or calculate it because the numbers in the equation actually give us the vertex. The vertex is h, comma, k. And if I look in my equation, there is an h and a k in the equation. Those are going to be numbers. We're going to pull those numbers from the equation, and they are going to make the vertex. Now, we have to put a little side note about the h. This h here, when we create the vertex, the formula has an x minus. It doesn't mean the h is minus, though. It's just the formula that is minus. So an easy way of remembering h is that we need to take the opposite of what's inside the parentheses. So maybe remind yourself of that. So you're going to take the opposite of what you see in the parentheses, and that's because the formula has an x minus in it. So the h is a separate value you're going to take the opposite of. So we know how to graph, but we don't know how to graph in this form. So that's why I created this little box for us. What was the first thing that we graphed, Haley, when we were graphing in the other way? What's the first thing we always found? We found x. Yeah, we found x.
Or it's a line of.
Yeah, so the first thing we did graph was the line or the axis of symmetry. We're still going to graph that first, but it isn't negative b over 2a because I don't have an a and a b in the equation. We have an h and a k. We actually have the a, but not the b. So the line of symmetry is x equals h. Whatever number represents h is the line of symmetry. And I'm going to put a little side note down here again. Remember, it's the opposite of what you see in the equation. So h is always opposite. But we're still finding the axis of symmetry. It's the line at x equals h, not negative b over 2a. So remember, this is a different form. The second thing, we're going to plot the vertex. That was the second thing we graphed. We graphed the axis of symmetry, and then we graphed the vertex. The vertex I just said above is h comma k. So it's still an x and a y point, but that x and y actually are numbers in the problem represented by h and k. And remember, the h is opposite. Only the h, because it's the number inside the parentheses. K is not opposite. That kind of looks a little sloppy. And I know it seems a little confusing now. It'll make more sense once we work through a problem, just the way it was the last time. What's the third thing we usually graph or find? So we find the axis of symmetry, we find the vertex. Emma, what else do we find when we graph? What's that other point that we find?
The y-intercept.
Nice, the y-intercept, and we're still going to find that. And then we're still using symmetry to plot one more point on the opposite side, which we have done before. So we still plot one point on the opposite side on that line of symmetry. And then we draw a parabola, that's the name. which remember is really a U, through the points. All right, so let's see if we can try this. We're going to follow this step by step. We're going to look at this new form and try and find the information in the new form. So if you scroll down and look at example 1, notice it has the same 3 pieces of information, but the equation looks different. So the first step that we did before was we listed A, B, and C. We're still going to do that first step, except we're going to list A, H, and K this time. So we usually write A, B, C, but now we're listing A, H, and K. So Haley, what number would represent A? -2. So A is still in the front. And then it says x minus h squared plus k. That's this new form. Haley, what number do you think h is? It is. Nice job.
Opposite what you see.
So opposite of what you see for h. H is just the 2. So opposite of what you see. Nice job, Haley. So even though it says x minus, h is actually opposite. And then Haley, what's the k value? 1. Nice. So now we have A, H, and K. Now you're going to like this form because it's less work. To find the axis of symmetry, it is just x equals h. So if you look to see what you have labeled for h, then you have no work to do for the problem. Haley just told us h is 2. So without doing any work, once you know h, that's your axis of symmetry.
Done. Easy.
Done. No work. X equals h. So you have to recognize what the h is, but there's not any work. The vertex are the letters h, comma, k. So again, no work. Bill, what are h and k in our problem?
2 and 1.
Yeah, so that's the vertex. Again, no work. So 2 of those pieces that were a lot of work in the other problem are no work in this form. But the y-intercept was no work for the last problem because it was 0, comma, c. There's not a c. In this form, there is a little bit of work for the y-intercept, a tiny little bit.
Just a little bit, not a lot of it.
To find the y-intercept, we're going to have to do a tiny bit of work. You're going to have to let x equal 0. The y-intercept is going to be a point that we have to now calculate. And that point is at 0, comma, something. And we're going to have to find that y value for the y-intercept. To find the y value, you're going to take the original equation and we're going to let x be 0 because we're finding y when x is 0 or on the y-axis. So the equation says -2, x is 0. And then it says -2, that number is squared, and then we have a +1. So this is the only piece that you actually need to do work for. And we're going to use PEMDAS just like we did in the last type of problems. So we used PEMDAS before, we're going to use PEMDAS again. We have parentheses this time, and PEMDAS says we need to start in the parentheses. So Haley, if we start in the parentheses, what is 0 minus 2? -2. -2. So now in the parentheses, we have a -2. It's squared, and then we have a +1. The next part of PEMDAS is exponents. Well, we have an exponent at -2 squared. Jason, what is -2 squared?
Positive.
+4. All right, the next part of PEMDAS is multiplying. Well, I'm going to multiply here, and I get -8. And then when you add 1, you get -7. That is the y-intercept. So that's the part that requires work. So it's opposite of the standard form. In standard form, we had to do work for the axis of symmetry, work for the vertex, but no work for the y-intercept. And now this one is the exact opposite. That's the only one you have to do work for. So it's like less work because one of the 3 requires work instead of 2 of the 3. So we're going to graph it, but we're graphing in the same exact way. So to graph, you start by graphing the axis of symmetry. We're going to make a line at x equals 2. So go to where x is 2. Make yourself a line. So that's x equals 2. So it's still a line of symmetry. It's still an axis of symmetry. The next part is my vertex. That vertex is at 2, 1. So over 2, up 1. Again, that part hasn't changed. We just found it differently, but we're graphing the same thing. Finally, our y-intercept is at 0, -7. So on that dark y-axis, we're going down to -7. And then here's where we use symmetry to graph the line on the other side. So over 2 to the line, over 2 on the opposite side. And that gives us our third point. That part's the same. So using symmetry to graph, whoop. And then draw your parabola, your U. So we find the information a little differently, but the graph looks the same. The shape is still a U. The last part I want to look at here, this graph goes down. The A value is what tells us the direction of the graph. Well, A is negative. If A is negative, we said the graph goes down. That doesn't change just because I have a new equation to look at. So if A is negative, that's why my graph is going down. Does anybody have questions? We're going to graph another one together, but are there questions that you have? I think you'll feel a little more confident like when we look at a couple examples. It does seem a little weird.
It's easier.
It is,
easier
yeah.
than what you did in the last
It is easier. Like once you get the hang of it, it definitely is easier.
Just remember that H is opposite is the big key that a lot of students forget.
Yes. All right, so let's look at extra example 1 because you can't just do example 1. You got to do an extra example 1. A, H, K. So as Mr. King said, when you're writing H down, make sure you write the opposite. TJ, can you tell me what A, H, and K are in this problem? Emma, can you tell me what A, H, and K are in this problem?
1/2 for A.
Good. Opposite for H.
So then would it be just 3 or?
Perfect. And then
Okay.
K
And
is?
then -5.
Nice job, Emma. Very good. All right, so that's the tricky part. Knowing or remembering that the H is the opposite. Now we're just going to work through and find our information. So on the side here, I'm going to remind ourselves. Axis is symmetry. Oh, that should be symmetry there, not symmetric. Oh, it is symmetric.
It is.
Yeah,
Not too bad.
yeah. Whoopsies. All right.
Better than axis is symmetry, Bob.
Ah, yes. Ooh, cinnamon buns. That would be good though. You must be hungry again.
Oh, yeah.
So x equals h or x equals 3. No work necessary. So it's no longer negative b over 2a. We don't have to do anything for that problem there. The vertex is h comma k. Well, Emma just said h was 3 and k is negative 5. Once you have them listed, it makes it easy to just write them down for the vertex. That's why it's called vertex form. The vertex is in the equation. The y-intercept is the one where we have to do work. So we have to let x equal 0, and we're going to have to plug it in. So this is the part of the problem where we have to do a little work. So our equation says 1/2. If you'd rather write 1/2 as 0.5, feel free to do so. We can change that to 0.5. X is 0. That's the most important part for finding a y-intercept. X is 0. And then it says minus 3 squared minus 5. And then follow PEMDAS. So Bill, 0 minus 3 makes?
-3.
And then when you square -3, Bill, -3 times -3 is?
9.
9. All right, Bill, you're doing good. What is half 0.5 times 9? That one's tricky. Half of 9.
4.5.
Yeah, and then the last step, 4.5 minus 5.
-0.5.
Perfect, Bill. Nice job. That's the y-intercept. And I'll just write it on the side here. So x is 0. X is 0 every single time for the y-intercept, but it's no longer 0c. It's now at a value we have to calculate, 0, -5. So 3 pieces of information, still graphing 3 pieces of information, going over first and graphing that dashed line where x is 3. So x is 3, making a dashed line. The next point on that dashed line down to -5. And then graphing 0 and -0.5. -0.5 is in between 0 and -1. So just put a point in between 0 and -1. And the values, I mean, those boxes are so close together. If I make my point big, it kind of takes up that whole box. Finally, use that symmetry opposite process. 1, 2, 3 on the other side. 1, 2, 3. And then I have my opposite point.
Sounds like you're ready to do the salsa.
Oh, we could. I don't know the salsa though.
I can teach you.
Oh,
It goes 1, 2, 1, 2,
I think I could handle that. Here's our parabola. This parabola goes up and it opens up because A is positive 1/2. So if A is positive, it goes up. If it's negative, it goes down.
Same as before.
Yeah. All right. So we will not do the checkpoint problems. We'll save those for tomorrow. Instead, maybe Mr. King will go over a couple of homework problems with you. Plenty of time to go over them.
Plenty of time.
So if you travel over to Google Classroom,
You can play a train or an automobile for your travel.
oh, that would be good.
It's a good movie too. Have you ever seen that movie?
I did see that movie.
It's a good one.
Oh, his name is like blanking me now.
Steve Martin.
Yes, thank you.
And
And
John Goodman.
John Goodman, yeah. That's the one I was thinking, yeah. All right, so in Google Classroom, pull up that worksheet. Oh, I don't have it in my Google Classroom. That's why I can't find it. It's not in my Notability. Slipping, Mr. King.
It's Beautiful day for slip and slide. Sun's out.
Okay, it might be a little cold still.
What do you think, Amy?
Yeah, I totally agree with you, Haley. Me neither. All right, here it is, Mr. King. We got it up and running.
And we have numbers we're doing.
Just the one person there. I think there's
Gotcha.
one.
Okay, numbers 1, 2, 3. We're doing a little matchy. Jason. Number 1 should stick out because if we look at our leading coefficients, this is positive, negative, negative. Which is the only graph that is positive, Jason? A, B, or C?
C.
Thank you, sir. Thank you, sir. So that's going to help you out with C, your first answer. Okay, next. We've noticed that,
Maybe skip that line and do the next one.
yep, we'll skip that one down there.
Use process elimination.
Yeah, use process of elimination. Let's do a couple of these bad boys here. Why don't we start off with number, what do you think, Haley? Pick a number. 5, that's a great number to do. So we revisit our formula. Y equals A times X minus H, square it, and then add your K at the end. So the first step we're going to do is we're going to find our vertex. And that is our line where X is going to equal your H. So if we do this, Emma, what's my X going to be? What's my line of symmetry? I said vertex. What's my line of symmetry here? I'm sorry. I'm getting above myself.
Is it 2?
You're right. Good. So our H is the 2. What's our A and what's our K?
K is -1
Good. And then
and A is 1.
yeah, absolutely. So A is 1. H is again the opposite one, which is 2. And then K is -1. So the first thing we're going to look at is our line of symmetry. If you remember, our formula for that is just X equals H. That's all. So Emma already told us that our H is 2. So we're going to graph a dotted line on 2. Now we're going to find a vertex. And our vertex is our H and then our K. So Bill, what is our vertex here?
2, -1.
2, -1. You put a big dot at 2, -1. And then lastly, what we're going to find is our y-intercept. And that's going to be 0, and then we're going to plug in for y. So for this one, we're just going to plug in 0. So y equals 0 minus 2, square it, minus 1. Using PEMDAS. We do inside parentheses first. So we get -2 squared minus 1. We already did this one before. -2 squared is going to be 4. 4 minus 1 gives you 3. Our y-intercept is going to be 0, 3. Really, once we have our y-intercept, we gotta mirror it, right? So we go 2 spots over. You do your mirror, you draw your U through. Questions on what we just did there? All right, Bill, why don't you pick a different one for us to do?
Seven.
All right, yeah, 7's a great one. All right, Bill, hit me with the A, H, and K.
A is -2. K
Good.
will be -1.
Yes, sir. And then K?
And K would equal -4.
So we got 3 negatives there. Okay, first step is we're going to do the line of symmetry. And then the symmetry is pretty easy. It's just x equals h. So x equals -1. The other one that's real easy to do is the vertex. And we know that that is going to be hk. So -1, -4. So go ahead and graph those. Jason, what's the last step we do? Plug in. Haley, what should we plug in for x? Yeah, we plug in 0. So our last step is we get y equals -2 times 0 plus 1 squared minus 4. Then you just use PEMDAS. -2 times 1 good. So our y-intercept, remember, is 0. And then our y value, which ends up being -6. Once you have your 2 spots, 2 points, you mirror it. And then you draw your parabola. Questions? All right, so the rest of the time is yours. If you want me to go over any more, I'd be more than happy to do another 1, 2 with you. So I have a couple minutes left. If not, go work on your own, get this in. It's a new concept, but it should be a little bit easier than what we just did. So
Don't forget to submit the review worksheets from this week if you
Oh,
haven't
yeah.
done so already.
please.
I don't remember who took the test.
Get everybody on there too. Sorry for being a little tardy. Oh, 9th grade drama, if you can remember that.
It happened.
You remember that, Haley? Oh, 9th grade drama? Running to Mr. King's office crying. Who remembers those days?
It's tough.
It's tough being in 11th and 12th grade. Dude, all our students, it's been a tough year, but I'm